Hello everyone. Today I'm going to be answering some of your questions. Now some of these questions are ones that have been left as YouTube comments and others are from Instagram. So I asked you for questions on Instagram and I was really happy that so many of you did post something and there's some really thoughtful, nice questions there. So if you don't already follow me on Instagram as well and you want to stay in the loop next time, then I'll have a link in the description. So I've got my laptop here and I'm just going to go through some of the questions that I think would be really interesting to answer. So the first part of this question is, if I'm bad at math, should I study physics or computer science? I find it hard with these sorts of questions when people ask me like exactly what they should be studying or for that sort of life advice, because of course I don't know what you're going to actually excel at. I can only speak from my experience, but I think there's probably a lot more advanced sort of calculus in a physics course than there would be in computer science. Computer science would be more of a discrete math. Both those subjects are going to have elements of math in them and they'll probably both end up being tricky if you don't have any math background. But I'd probably say you can get further in computer science without the knowledge of calculus or differential equations or some of those sort of quite tricky math concepts. The second part of this question is the common misconception that physics is hard even true, or does it just stem from the concept that it's easier for some people to grasp and harder for others? There is definitely sort of the idea that physics is a difficult subject, especially when it's being compared to other subjects. And I think it's true to some extent. Physics is difficult, but one of the main reasons why it looks so difficult to people, especially that aren't in physics already, is because the kinds of questions and assignments and work that you have to do studying physics, you can't just look at it as an outsider and understand what's being asked. Early on in physics, you get swamped with notation, conventions, and you really get sucked into this very niche way of describing the world, and it's something that can be quite isolating, especially things like the notation. And when you get into doing quantum mechanics with Dirac notation, it looks like you're writing in an alien language, so it's really not accessible to someone who's not studying it. I think that's why it seems so hard, because you can't jump in. You have to sort of start at the most basic building blocks and go from there. Alright, another question was, can you give me some tips on how to learn and understand college level maths and physics? I'm currently taking real analysis, electromagnetism and quantum chemistry. The problem is that it takes me a lot of time to do problems and apply concepts. If you can give some advice on how to increase the learning rate, then that's going to be helpful. It's true that physics and math problems at a college level are going to take you a long time to do. That's kind of the point that separates them from, say, high school physics, is that as you learn these new concepts, they can be so confusing at first that you have to work through them slowly, really slowly, to understand them. I spoke about this in one of my last videos where I said one of the things I regretted during my degree was not actually going slower myself and taking the time to understand these concepts, because to some extent, I don't know if the question is asking me how to actually understand them deeper or how to do well in them, because you don't just have to be smart at the physics here in college physics. You've got to be smart at other things, like when to stop learning, like when you've learned enough that you need to move on to the next concept. You need to know what you need to study and what you need to learn. If you try to learn everything that's presented to you incredibly deeply, I don't think you'd ever be able to pass, because there's just so much to do. You need to be thinking in terms of, I guess, how can I be most effective at doing some of these example problems, but not every single one. So you have to be able to look for like common trends in what you're being asked and pick out trends within problems and ideas and just learn those. It's, I think, almost impossible to try to do and accomplish every concept and every problem. So to the Instagram comments, there's one, what is your specialization in studying physics? So in my undergrad degree that I did in New Zealand, I double majored in physics and maths, and I didn't specialize beyond that. I know some unis offer, especially the big unis with a lot of courses, offer specializations like medical physics, theoretical physics, maybe optics, something like that, and they offer that at the undergrad level. I just had that sort of broad physics umbrella, even though I did a lot of, say, astrophysics courses and even some of the more mathematical physics. I didn't really have a label. Now that I'm doing my PhD, I'm working in an area of biophysics, but it's still just under the umbrella of PhD in physics. Direct notation, and also how many females study physics. So I have made a video talking about direct notation before, and I'll try and put a link to that here. But the second part of the question, how many females study physics, the answer is not many, which is a shame, and there's definitely not many. I probably say in my undergrad course, I was at quite a small uni, and the whole class, like all the physics majors, there was probably 30 people in total, and of those maybe 3 or 4 girls, so maybe a 10%. Yeah, it's really a shame, and it does make it harder, I think, for women doing physics to not be surrounded by sort of like-minded others in a sense. But so a lot of courses are bad. I know math and computer science is sort of similar numbers. I was just grateful I wasn't the only female, which I know some people have been through that, and it sounds a lot more isolating. What books can I use to study through the summer right before college, physics undergrad? Well, if you're sort of just coming out of high school and going into physics undergrad and you want to get ahead in some sense over the summer, I would probably just recommend looking up which textbooks are going to be used in your undergrad course in that first semester and reading those, because it means that as soon as you start, you will be already familiar with the content. And I think one of the most vulnerable times for people in terms of like dropping out of uni or feeling overwhelmed or behind is right at the start as you're starting a new course. So if in that first semester you look at the content, you're like, oh yes, I've done some of this, I know some of this doesn't seem like such a big jump from high school, then you'll probably be quite all right at, you know, getting back into the rhythm of things and moving from there. If instead you hit that first course really overwhelmed, scared of the concepts because they seem so alien to you, then feeling behind from the start is really not going to be helpful. So like, I know in undergrad first year I used a physics textbook by Sir Wayne Jewett, but I would just pick whichever one is listed on your uni's website as being the undergrad textbook. What moment or achievement of your academic career are you most proud of? I mean, there's probably a lot of things I feel quite proud of and things that I did in like my academic career that I look back on really fondly. Probably the proudest moment though would be when I finished my honours course here in Australia, and I was able to get first class honours, which is a certain grade, and it's the grade you need to be able to do a PhD straight away without having to do a master's, and you can do the PhD with a scholarship. And because of that, it's really like if you don't get first class honours, which means an average over 80%, then you're adding like a couple of years onto your study because you need to go and do that master's, or maybe it might just be worth going out of academia and doing something else. So I knew that my grade there would be a turning point for me, and I so badly wanted to get first class. but at the same time I was starting a new uni and I felt really behind because all the courses I was doing, I feel like my background at a previous uni wasn't quite the same, so I feel like I had a lot of catching up to do in those first few weeks, and it was also really intense coursework, and it was really quite depressing really to be going through that and to be so stressed about trying to get good grades because you only had one shot. I remember thinking, like, during some of the really hard assignments and coursework that, oh, if I get first class honours in this, it's going to be the greatest miracle that ever happened. But somehow I did. I think it was more of an endurance test rather than an intelligence test. The honours system, it was really like, can you survive handing in daily assignments, doing all these exams with not much of a break, and can you just keep going to the end? And I think, like, I was able to just keep going, and that's what got me through. So I think some aspects of study are really an endurance test, but that was something I was really proud to get through. What's your learning process, and how do you manage to understand such abstract and difficult ideas? So I guess again that's the perception that physics is really hard, which I guess it does have a lot of really abstract ideas. And what's your learning process? I sort of said before, my learning process was cramming a lot of things into my short-term memory. Not a great learning process. I spoke about a better learning process in another video, the Feynman technique, which is don't just try and read and absorb the material by yourself. Try to work with a group and explain to them what you're learning. I think that's one of the most valuable things I ever did, was not only asking my friends for help, but letting them ask for help and trying to explain things to them. It really lets you know what you understand and what you don't. In what ways has physics changed your perception of the world? I quite like this question. I think, yeah, a physicist or someone really interested in physics or math or science kind of does look at the world a little bit differently. I definitely look at natural phenomena and sort of wonder about the physics behind it. I think there's something to be said for trying to look at things rationally as well, and try to understand how things work, because so much of your physics education will be taking something that seems like a normal everyday phenomena or occurrence, or a ball rolling down a slope that most people will just accept as happening, and you're asked to break that down and understand why, understand what forces are acting, why they're acting, where they're acting, and how so many different elements add together to give the physical world around us. That is why I picked physics in the first place, because I loved looking at the world like that. I don't know, I guess it's asking why things are the way they are. And I think studying physics just sort of enhanced that type of thinking. I think most people come in with that curiosity, and going through the process for 3 or 4 years or more means that you're quite good by the time you finish at looking at things and having a bit of an answer for why they work. There's still so many things I don't understand, but the world is a big and complex place, and we can try to explain what we know, but there's a lot we don't know. I do have quite a few more questions, so I'm actually going to split this up and do a Q&A part 2 that I'll upload a little bit later. So if I didn't answer your question now, I'll try and answer it then, but also I'll try and answer it online. Thanks for watching, and thanks for sending in so many questions. I'll see you next time.